Hi there guys, and welcome back to another Python algorithmic tutorial. Today we're going to see the binary search. The binary search is an algorithm that searches an element through an array. So let's suppose we have this array, and this array is fully sorted. This is one of the prerequisites of the binary search. It needs to be fully sorted in ascending or descending order. And let's suppose we would like to search out for the number 4. The first things that the algorithm does is to determine which is the left index, in this case is equal to 1, even if we know our arrays start from 0, and the very last one, the right, that in this case is 13. And since the algorithm is binary, it cuts the array into two parts, so it gets the midpoint. Well, the first things that the algorithm asks once he has done all of these things is 4 equal to the element we see at the mid index, so in this case 10? If 4 is not equal to 10, and we know that the array is sorted, we need to think about the fact that 4 is before 10 if the array is sorted in ascending order. So what the algorithm does is to get rid of the mid index, get rid of the right index, and knowing that 4 is smaller than 10, it gets the right index at 9 and it gets the brand new mid index at 4. Do you follow me? 4 is smaller than 10, so it must be on the left side of the array, so the right index needs to be shifted. And now we have found the element. Just for purpose of clarification, 1 plus 6 in this case, even if it's not the right case because the left should be 0, but 1 plus 6 gives 7, that divided by 2 and take the integer part gets 3. So we found the array in that position. So we found the element in that position, the mid position. Now let's see it in Python. So we can define a function, and the name of the function is binary search. We have an array and an element that we would like to search. The first things that we are supposed to do is actually the following. So the first thing is to get the length of the array and saying which is our left. Let's give it the left name. And it starts from 0, not from 1. Array starts from counting from 0. And the right index. The right index is, in this case, n minus 1. Always remember that len gives you the length of the array, but the length of the array is actually, in terms of indexes, it's the length itself minus 1. So what are we going to do right now? Until the left part is smaller or equal than the right part, always remember we have an array, we get the left, we get the right, we get the mid index. If the element is smaller than the mid index, we are getting the right index, one index before the mid index, then we move the left, then we move the right. We are cutting our array into two parts. This is why binary actually, right? So the first things that we are supposed to do is, while left is smaller than right, let's get the mid index, which is left plus right, divided by 2. This symbol in Python gets you back the integer part of the division. So if you are going to do 7 divided by 2, it's going to give you 3.5, so 3. If you're going to do 11 divided by 2, it's going to give you 5.5, so 5. So while you have this, what are you going to do? You're going to check, is the element smaller or bigger? We are getting our array in ascending order in this particular example. So if the element is equal to the array at the mid index, just return true, because we found it. Otherwise, if the element is smaller than the array at the mid index, so if the element is smaller, as in the case that I showed you, what are we going to do? The right index is supposed to be mid minus 1. Otherwise, if the element is bigger than the array and the mid index, the left should be moved more left. It should be moved more to the right actually. So it's mid plus 1. In all the other cases, just return false, because we found nothing. Let's test it. So our array is 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, stupid me. Between brackets. And let's print binary search within this array, and I would like to search for the element 9. Found it at the very end. Remember, the array must be sorted in this case, always. Let's search for another number, 3. It is true, found it. Let's search for 0. Not found it, because it has been cutted this array into 2 different parts until it founds at this position, actually, it founds that it has found the element. And this is it. This is all about this short but very effective algorithm. It found it. Let's play around with it. It found it. It found it. Not found it. And this is it. I hope you learned something new, and as I'm used to say, don't hate, collaborate.